7th graders, Ms. Summers is going to be trying to make this video from her desktop, meaning I am no longer standing at the smart board, but I'm using my mouse to teach this one. So if my handwriting is worse than normal, please bear with me, but the content will be the same. Here we go. So you are learning 2.9 today. That is, I can use powers and exponents in expressions. If you're following along with your book, you can be looking at page 126. Please remember to come with 2 things you've learned and 1 thing you are wondering when you come to class for this video. Powers and exponents. A product of repeated factors can be expressed as a power. That is using an exponent and a base. Words. Okay, so the gist of this is you have a base, your one number here like 2, and your exponent, your tiny little number at the top, and that tells you how many times you're going to multiply your base by itself. So, and they use the word factor, but I know a lot of you get mixed up when you use that. Hopefully you know that factor is one of the numbers that you use to multiply with to get a product. So, we have our base of 2, meaning 2 is the number that you're constantly multiplying, and our exponent of 4, which is how many times you multiply 2 by itself. So 2 times 2 times 2 times 2. That's a power. So a power is made up of a base and an exponent. So if you look at 3 times 3 times 3 times 3 times 4 times 4, you can actually write that as 3, your base of 3, how many times you're multiplying it? 1, 2, 3 times with the exponent of 3 times that number 4, which you're multiplying by itself 2 times. 1, 2. Wow, this pen is not as great as my handwriting, but we shall survive. So, looking below, you can write expressions using powers. Write each expression using exponents. So what you can do here is find what different types of bases you have. What are your common factors? So I see I have 1/2, 1, 2, 3 total times. So that's actually 1/2 times itself 3 times. An exponent of 3. That 3 should be smaller, yes. Then that's all multiplied by 3 times 3 times 3 times 3. So that's 3 4 times, so that's 3 to the 4th power. Okay, so, and kind of this is when you use that associative property, you can kind of group things based on what's in common. And so I split them up like that. Then you see this works with variables as well. So if we have A times B times B times A times B, I'm actually going to find my common terms as A times A times B, B, and B. So what I really have is A times A, which is the same as A to the 2nd power, or we normally say A squared, and then B to the 3rd power, or we say A cubed. And so this is my simplified version, writing that multiplication with exponents. One thing I did not mention, and I should have, is that really powers and exponents, that's what's used to represent repeated multiplication. Okay? Just like we use multiplication to do repeated addition, powers are used for repeated multiplication. Okay, so there's kind of 3 on the bottom here that you should maybe try on your own, and then pause me and come back and see if you have the right things, and then kind of use your book as a reference as well for anything that you are wondering. So again, here I'm going to count up my common factors, and I have 2/3 once, 2/3 twice, 2/3 3 times, and a final of 4. So that really is 2/3 to the power of 4, or 2/3 times itself 4 times. And that's all multiplied by 7, that's a multiplication sign, 7 2 times. To simplify it like that. Okay, so I just write that same expression just using exponents. So the same thing, just a little bit more condensed. And I have m times m times m in this next one. So that's m to the 3rd power, or cubed. And that's all multiplied by n, 1, 2, 3, also to the 3rd power. For me, since m comes before n in the alphabet, I'm going to write that in that order. and leave it that way. This next one, I see I have 2, so I'm going to write times 2, and 2 is just to the first power by itself, and that's going to be times 3, 1, 2, 2 times, and then that's times a, 2 times, a is the second power, all times b to the first power. Normally when you do these, you're going to put the one with the most powers, the highest exponent, to the left, okay? And why don't you, I'd like to challenge you to look in your book to see how they have this one written. I believe in there they have the variables first rather than the numbers first. Moving on, we can look at our tens, our powers of tens. So exponents can also be negative, not just positive. But if you look at this chart here, then you can see kind of what patterns you see when 10 has an exponent. Negative powers are actually showing repeated division, whereas positive powers show that repeated multiplication. So we see 10 to the third, you really add on 3 zeros, and that's actually 1,000. 10 to the second is the same as 100. And notice how we're going down every time, third, second, first. It's really just like we're dividing by 10. So when we get to our negatives, it's like we have 1 over 10, and when we get to negative 2, we have 1 over 100. Okay, so that's kind of a tricky thing, but I think once you get the hang of it, we kind of deal with those reciprocals, or those multiplicative inverses, which we know Miss Simmers loves those words, and that helps us kind of remember to flip our numbers around. But do remember that something like 10 to the negative second is equal to 1 over 10 to the second, not negative 100. So that negative exponent doesn't make the multiplication negative, it just makes it more like division, and you're going to end up with some really small numbers in fraction form. So following along on page 127, we see that any number to the power of 0 is 1. Okay, this is something I make my 8th graders repeat over and over again later in the year. Any non-zero number to the 0 power is 1. So I could put any number. It could be 4 to the 0 power, and that's going to equal 1. It could be 100, 137 to the 0 power, and that's also going to be 1. Okay, so any non-zero number to the power of 0 is going to have a product of 1. And you can see that all in numbers or in algebra right here. So I was going to evaluate 2/3 to the 4th power, and hopefully we remember that evaluate actually means to solve to find a numerical value. We are going to look at 2/3 to the 4th power is the same as 2/3 times 2/3 times 2/3 times 2/3. So we're writing our power now as a product. Because powers represent repeated multiplication, we're going to kind of work backwards and have it written as a product, meaning multiplication. So when you do that, hopefully we remember to multiply fractions. We multiply the numerators and multiply the denominators, and when we do that, we end up with 16 over 81, and that is what 2/3 to the 4th power is after you evaluate, after you solve. So why don't you give the next one a try too. This one has a negative exponent, so this is really the same as 4 to the negative third is really 1 over 4 to the third. So we write the power using a positive exponent by doing that multiplicative inverse, reciprocal or reciprocal, that helps you, and flipping that over. So hopefully we know also that that 4 to the third is 1/4 times 1/4 times 1/4. And then 4 times 4 is 16 times 4 again is 64. Evaluating a squared times b to the 4th if a equals 3 and b equals 5. This goes way back kind of to our first few lessons in chapter 1 when we replace our variables with a numerical value, and we work on solving that way, or evaluating in this case. So a squared times b squared, we really plug in 3 for a, so that's 3 squared, or 3 times 3, times 5 to the 4th, which is 5 times 5 times 5 times 5. So that's really looks like this. If we write it out as multiplication, which is a lot longer than if we use exponents, we can solve those separately. 3 times 3 is 9. 5 times itself 4 times is 625. And altogether, that's going to be 5,625. So what this means is this number is the same as this written as exponents. All right, try these couple ones by yourself, and then we can go over them. So 1/5 to the third power, that 1/15th rather, 1/15th times that 1/15th times that 1/15th. What that really is that you multiplying 15 times itself 3 times, and you may need to, I think we do, we may let you use the calculator a little bit more in this chapter, but in case you didn't, 15 times 15 we know is 225, and you may have to multiply that again by 15, which I'm making a mess here, and do your regular multiplication. 5 times 5 is 25, 5 times 2 is 10, plus 2 is 12, 5 times 2 is 10, plus 1 is 11. This is really messy. I'm so glad you guys are bearing with me here. And then I do my multiplication all the way through, and I add to end up with 3,375. So 1 over that amount is what is going to be the same as 1/15 to the third power. So hopefully we're realizing these exponents make our lives really easy. Okay? 5 to the negative fourth power. Hopefully remember that we need that negative exponent means we're going to kind of flip this around for our multiplicative inverse. So we have 1 and 5 to the fourth, which is the same as 1/5 times 1/5 times 1/5 times 1/5. Well, 5 times 5 is 25, so we have 1/25 times 1/25. I simplify it that way. And then you can finish that out. 25 times 25. Again, if you are not confident in your partial products, you can do 5 times 5, which is 25. You can do 5 times 20, which is 100. And then 5 times 20 again, which is 100. I'm making a mess. This isn't clear. 20 times 20, we are 400. So we're really going to end up with 625 all underneath 1 here. You guys are sports to be able to follow along with this writing. Right. Last one on this kind of deal. Since we have c to the third power times d to the second, we really just need to plug in our values for c and our values for d. I'm kind of getting ready for distribution here, it looks like. So we have negative 4 to the third power times 9 to the second power. This is a negative number, not a negative exponent. Hopefully you remember that a negative times a negative is a positive, but a negative times another negative, that odd number of negatives is really going to be a negative number. So this is going to be a negative 64 times 9 times 9 is 81. And hopefully we know a negative times positive is a negative. You can work this out using your regular multiplication. 1 times 4 is 4. 1 times 6 is 6. 8 times 4 is 32. 8 times 6 is 48. Plus 3, 451. Add those together for a total of 5,184. Again, I'm liking those exponents a little bit more and more as we go here. Right. So that was kind of painful with the pen writing, but I think we got through it just fine. Don't forget that you can rewatch this video, look at the examples in your book a little bit more in detail. Go check out Ms. Hoff, Mr. Lentz, or Ms. Griner's pages if you want to, or check out those personal tutors in your online textbook. You guys rock. We'll see you next time.